So without further ado, let's get started and listen to Sashko Stubailo's talk.
All right, so Meteor, effortless full stack JavaScript. So it's 2017 now. It's been a couple of years since Meteor started out. So what is Meteor in the context of JavaScript development in 2017? That's probably the main question that I'm going to try to answer today. So to start, I just want to recap some of the stuff that's been happening in the Meteor community recently, things that have come out in the Meteor community in the last few months. So the current release of Meteor is Meteor 1.4. Started out a couple months ago, and the main focus in Meteor 1.4 has been on the developer experience. So we've been working really closely with as many production developers as possible, people who are using Galaxy, people who are running Meteor apps, that are getting more and more complicated, larger teams working on those, and making the experience better for those people has been our top priority. So we upgraded Node and MongoDB to more stable versions, new storage engines in MongoDB. We've made it possible for us to release Meteor releases much faster and more quickly respond to contributions. Made it faster to run your Meteor app and to download the packages in that app, and also made the rebuild times dramatically faster. Meteor 1.4.2 was just a total rebuild of the way that your app would rerun, and really brought it up to par with modern JavaScript tooling. Just this morning, we launched the final release in the 1.4 series, which was 1.4.3. And 1.4.3 was awesome because it was almost entirely community-driven release, possibly our most community-driven release yet, with over 26 contributors contributing to the stuff in there. Had some great stuff about upgrading to NPM 4, further decoupled Blaze so you could make your bundle smaller, and also improved, again, our ability to publish new Meteor releases more quickly so that we could more easily release fixes from the community. And that's definitely one of the things that we've been emphasizing the most over the last 6 months is it's been easier to participate in Meteor as a project than ever before. We moved our blog to Medium specifically so that it was easier for people to publish community blog posts. And out of the last 6 posts we've done, 3 of them have been from the community. So I encourage you to come up with a blog post idea and get your thing published on there. And we have like 20,000 followers, so you can be internet famous. And we've made several detailed guides for both how to look at issues, how to respond to issues, how to submit pull requests, how to fix bugs, how to introduce new features. So if there's ever something you've wanted in Meteor but you've been missing it, now's the time to go and check out how to get that in there. And we've put in a lot of effort to decouple some of the main components. For example, Blaze is now 100% community managed under Meteor's leadership. It has its own website, its own release cycle. So we've been trying to make it so that you guys can get good stuff out of Meteor faster than ever before. We even recently hired a new core team member. You're going to see a blog post about this on our blog soon, but you might have seen Abernix around on the GitHub repository, Jesse Rosenberger. He lives in Finland, and he started out by triaging issues on the Meteor repository. He got way too into it and stopped doing the thing he was actually trying to do, and now is working on Meteor full time, helping out Ben by managing those issues and getting stuff through. So the other thing that's been interesting has been, keeping up with the pace of JavaScript development over the last 2 years. And it's surprising that it's just been 2 years since version 0.9. I picked 0.9 because of this great forum post I saw recently. It's this developer who's been using Meteor since that version and has gone through all these different transitions that everyone in the JavaScript community has gone through. Different methods of testing, different module systems, different view technologies, even different package systems, right? Sometimes you're using more packages from NPM, or you're using ECMAScript modules instead of require. Maybe you would using the package system and package scope variables before. But apps are getting more and more complex, and the technologies of how you write JavaScript as a core language are changing even faster than that. So it's been interesting to see Meteor develop from that version through that extremely tumultuous time in the community. So what's next? How are we going to continue to develop to become the best modern JavaScript tool out there? So I started out this talk by saying Meteor is going to be about effortless full stack JavaScript. So think about what the JavaScript language has, what it offers, what it could offer, and that's what we're trying to build. So Meteor 1.5, like I said, 1.4 was about development speed and development velocity, enabling you to scale your team up. Meteor 1.5 is going to be squarely about production performance. So It hasn't always been easy to make your Meteor app start up faster, load quickly. You could do it, but you had to be a Meteor hacker like these guys from Qualia over here. So in Meteor 1.5, we're going to make that way, way easier. And I have a super sweet video coming up that will explain exactly how. But the main two things here are reducing the dependencies of the Meteor core. So when you create a Meteor app from the start, it's going to be much lighter than you've ever seen it be. And the headline feature in Meteor 1.5 is going to be something we call dynamic imports. And dynamic imports are a new JavaScript standard, right? So you guys have heard of ECMAScript modules, where you can now use the import keyword to load code from other parts of your app or from packages from NPM. And you might wonder, why that and not some other syntax? And it's because that's the standard in JavaScript. And there's a new standard now for loading those modules after your app has already started up. And so now we think is a great time to implement that feature into Meteor so that you can take advantage of this new standard. And this diagram here is very simple, but the main idea is you don't have to load all your code up front. You can load some of it later. People sometimes call this code splitting. So before I get any farther into it, I'd like to leave the floor to Ben Newman, who's going to tell you all about this new feature.
Hello, everyone. This is Ben Newman. I'm currently in New York, but by the time you see this video, I will be on vacation in Costa Rica. So that's two good reasons I was not able to be there in person, but I hope you'll accept this pre-recorded demo video as a substitute for my physical presence. Tonight I'm going to be talking about two different performance optimization techniques that you can use to speed up page load times in Meteor apps. The first technique has been available ever since Meteor 1.3, and the second technique has become available only recently in the beta releases of Meteor 1.5. To demonstrate these two techniques, I've created a simple React-based Meteor app that imports React and then registers a Meteor startup hook that logs how long it took for the startup hook to fire, and then renders some React elements into a container that you can see over here in the main.html file on the right. So this render async function is, well, an async function. And you might wonder why that is, since it's not really doing anything async. Later, we're going to introduce some async operations. And I wanted to go ahead and make it an async function so that the performance characteristics are obviously the same before and after. Once render async is done, we do a little more logging about how long it took and then the sum of the startup time and the rendering time. So what does that look like in the browser? Well, here it is. It's not that exciting to look at. If we hold down Command-Shift-R to reload without using the browser cache, there's a little bit of flicker because React has to load and render this component into the DOM. The more interesting thing is how long this took. So getting to the startup hook took 900 milliseconds here. And that's a lot, although this is in development, so it's not minified or anything like that. Render async took not very much time at all, about 30 milliseconds just to do the rendering because all the JavaScript has already been loaded. And so if you don't like this trade-off, and especially if that startup time is much larger in your more complicated Meteor app, what can you do? Well, one technique, the first technique, the one that's been available for a while, is if you notice that you have imports at the top level of your module that you're not actually using at the top level of your module, you can push them down into the functions where they're actually used. So what's the point of this? React and React DOM and all of their dependencies will still be included in the initial JavaScript bundle, so they still have to be downloaded. But if we don't call render async, or we don't call it until later, we can, at the very least, avoid the execution cost of importing those modules for the first time. So that should speed up the startup time a little bit, and slow down the rendering time, or the time it takes to call render async, by about the same amount. And you might be raising an eyebrow at the fact that I've put these import declarations inside of a function. Technically, import declarations are only legal at the top level of modules. Because of the way Meteor compiles import declarations, this is legal, but if it bothers you, then we can definitely just use CommonJS. We can even use destructuring variable declarations here to make the syntax match as close as possible. So this code is functionally equivalent to what we had before, except that we don't actually import React and React DOM until we call the render async function. Sorry, I'm still getting over a bit of a cold, which is why my throat is scratchy. So, did that do us any favors? Well, reloading without the cache again, we can see that the Meteor startup hook is now down to more like 700 rather than 900 milliseconds. And render async took about 100 milliseconds instead of about 20 milliseconds. So that's the right direction for both of those. If you are diligent about taking your imports and turning them into requires and putting them in the places where you're actually using the imported symbols, then you can reap even more benefits across a larger code base. But this is all we have to work with right now. Okay, so if that feels like progress, it probably doesn't feel like much progress, right? We're still paying the cost of downloading all of that code. We're just executing it a little bit later. So what we would really like to do, if possible, is wait until we really need React and React DOM to even fetch the code from the server and evaluate those modules. So that is the second technique that has only recently become available as part of Meteor 1.5. It's implemented according to a proposal for the ECMAScript specification that will probably land in ES 2018 for dynamic imports. So there will be a built-in import function that works a little bit like require in that you pass it a module identifier string, but instead of returning the exports object for the imported module, it returns a promise for that exports object. And the promise is important because it's able to abstract the work of fetching the code over the network if you don't already have it, and also evaluating the module and returning the exports object. So this won't work as written, but because we're in an async function, we can actually just await the promise. And so, for instance, this await expression evaluates when the promise returned by import React DOM is fulfilled, and it evaluates to the same exports object that we had before with require, so the destructuring assignment still works, and render ends up being a function that we can call below. So I claim that this code is also functionally equivalent to the original code. And before I show you how that works, I'm going to go back to the require version just so that we can take a look at the network and see that I've sorted the packages by their size. The modules package is the one that contains all of your application node modules, and it's pretty big. Again, this is development, not production. There's no minification happening. 331 kilobytes. So remember that number. And now let's make the import changes again. Wait for it to reload. So the first thing to notice here let me close this and reopen it. The first thing to notice here is that when we reload, the modules package has gone from more than 300K to about 75K. So depending on your network speed, that will be more or less significant. We're doing all of this over localhost, so network is not actually slow at all. But that is a massive savings in code size. So at the very least, we've managed to slim down the initial JavaScript bundle quite a bit. And what effect does that have on our startup time? Well, Meteor startup now takes only about 500 milliseconds to fire. And of course, render async takes a lot longer. It was 100 milliseconds before, and now it's more than 500 milliseconds. And of course, that's because it is now having to do the work of fetching that code from the server. So I've been reloading without the cache a lot here. If I reload with the cache, you can see that the cost of downloading the initial bundle is not as urgent, not as problematic, and indeed Meteor startup fires sooner. Render async still takes the same amount of time though. And that's because in development, we're not doing any caching of dynamically fetched modules. But of course, we want to cache those modules that we've fetched, because if we do it right, we'll never have to request the same version of the same module again for the same client. To demonstrate how that works, I've actually deployed this very app with the current version of the code to Galaxy. I did this before the talk. And so you can see this works the same way, or at least looks the same. And behind the scenes, it's logging the same kind of information. This is the first time that I've requested this web page from this browser, so there's no caching of render async. But because we've minified things, the initial JavaScript bundle is a lot smaller, so the startup hook fires a lot sooner. But if I reload, you'll see that render async now takes just north of 100 milliseconds, which is a lot less, and that's all thanks to the fact that we are caching the modules that we've dynamically fetched from the server. So if you switch to dynamic imports and you start loading your code later rather than as part of the initial JavaScript bundle, in development, that will sometimes appear to make performance worse, especially if you end up calling the import function very soon after page load. However, when you deploy the same code to production, thanks to this caching system, the dynamic imports become almost free after the first time they are requested. And so let's try that actually with the inspector not open. There is some overhead to having the Chrome DevTools open while you run your app. So if you close them and redo your test and then reopen them, the timings that you'll get will often be much better. As you can see here, the combined time for Meteor startup and render is only 155 milliseconds. So that's pretty good since we started with a combined time of well more than a second. So I hope you agree that that's all pretty cool, and that at the very least in Meteor 1.5 you're going to have better tools for deciding when JavaScript is loaded and executed. To recap, the two techniques that I've suggested for speeding up page load times are to inline your imports so that you don't evaluate modules until you need them, and also consider taking modules that aren't really needed during page load out of the initial bundle by using dynamic imports so that they get fetched dynamically from the server later on. So if you want to get involved in this effort, there is a pull request for Meteor 1.5. There's already a lot of activity on it and lots of ideas for how Meteor could be faster in production. It's not just about dynamic imports. It's also things like making jQuery and underscore optional. Gosh, I thought I was better, but apparently not. Anyway, if you look at this pull request and get inspired, feel free to leave a comment, and I will be happy to give you guidance about how you might go about contributing to this awesome effort to make Meteor fast again. I'm sorry that I'm not there in person to answer any questions that you might have, but I will leave that task in Sashko's capable hands.
All right. Wow. So I'll try to follow that up with a little bit of maybe explanation about how that works and why it might be exciting to you in your app. This is a picture I found on the internet of a car that's been stripped of its internals to go faster. You notice to drive a car, you only need the driver's seat and not the passenger seat. And I think this is a good metaphor for code splitting. So the idea here is don't load or run code that you don't need. Just pretty obvious, but unfortunately sometimes harder to do than expected in JavaScript. So not only do you save on download time by making your code bundle smaller, less kilobytes, you also save on execution time because it actually takes time just to run the code, even if you already have it. In Meteor's implementation, there are a couple of specifics that you might not have seen in other code splitting implementations if you've looked into it. The first is that, as you saw in Ben's demo, there's absolutely zero configuration of any kind. You just replace some of your imports or requires with the asynchronous import function, and that's it. Now you're loading modules dynamically. The code splitting is also exact, which means that once you've deployed a certain version of your app, if that has a certain version of React, for example, you will never load that ever again. That's now cached inside your user's browser, and until React itself changes, that app will never download that from your server afterwards. This works alongside existing Meteor code, which is actually very important for Meteor developers in particular. Other module systems don't have that feature. So you can use your code that's written in packages that you wrote a long time ago side by side with your new code, which is using dynamic imports. And you can even use those dynamic imports inside your Meteor packages to load part of your package later after you imported it. And of course, like everything else in Meteor, it works the same way across your client code and your server code. So here's a pretty concise explanation of the difference between the code splitting feature you might see in some bundling systems like Webpack or System.js and the one you might see in Meteor. The main difference here is other bundle systems take the approach that they have you define a certain set of specific entry points, which create specific bundles on your server that are then loaded entirely when you go to a certain route, for example. And what that means is you might end up loading some code repeatedly, right? If one of your routes depends on some views and another route depends on the same views, you might load them twice, and then some systems also encourage you to make a separate vendor bundle so you don't load those twice. So it requires some configuration to get it right. And in Meteor's system, because every module functions as an entry point and you load only the exact modules you're missing, you're guaranteed to not load the same code twice, even without having to put in any extra configuration effort. So we're pretty excited about that. The other cool thing about Meteor is it's one of the few available totally JavaScript specification compliant import systems. So the first thing that's a little known feature of ECMAScript imports is that you're supposed to be able to assign to them. So if you import the same module in two places and you change the variable that you imported, it's supposed to change in the other place you imported it as well. Probably most people don't actually use that feature, but it's nice that we have it, I guess. The other thing that might be more relevant is how that translation works with debugging. So if you ever try to debug a module that has been compiled by something like Webpack, you might notice that the variables that you imported are not what you expected. So for example, here you can see we import this template variable from the Meteor templating package. And it might not be very surprising to you that in the bottom right in the debugger, you actually see the variable template inside there. But in many other module systems, what you'll actually see is either something like underscore template or something like underscore require 0, making it much easier to debug your code inside a Meteor-based app than in a lot of apps packaged with other module systems. So you can use this feature today. Right now, you could go home, or if you're already at home watching on YouTube, you can just type this inside one of your apps, try putting a dynamic import in there and see what happens. So we're on beta 8, and we're going to continue releasing new betas. So how does it work in a nutshell? Well, your module tree is still analyzed. It might look like the imports are totally dynamic, but they're not. Meteor still looks at all of the code in your application and all of your packages and identifies what can be imported. And then it identifies the entire module tree and which parts of it might be asynchronous. Still generates an initial bundle, and the initial bundle is composed of things that start from your entry point and are not async. So there's still an initial bundle that your browser actually loads. Because the client knows the entire module tree, when you import something that's asynchronous, it sends a list of the modules it doesn't have yet to the server. After it receives those modules, it runs them as usual. And then those modules are cached with a specific version number that's a hash of that module's contents, so that later on, if you request that same module again, it won't be loaded from the server, not only in the same browser session, but even across refreshes. Because that particular version of React, let's say, is never actually going to change unless they publish a new version. So why download it again? So in that sense, it might actually be better to make some imports dynamic, even if you do need them on app startup time, because they will simply load faster by not loading at all. Just to go over some of the use cases where you might use this, is basically anything that your users don't need to see right away. So if there's a rarely used part of your app, for example, your admin panel, you definitely want to make that asynchronous, especially if it uses extra packages. You might even want to make every single route of your app asynchronous, just because you can do that now. It's very easy. You should definitely asynchronously load any expensive components. So if you have a PDF viewer enabled in your application, or you have some sort of editor or some 3D component, it might be fine for that to load a little bit after your initial page load so that people can see some content right away. And there's always some heavy libraries like moment.js. You might not need to display that timestamp that's like saying how many minutes ago it was. The first thing that people see on your page, you might be able to defer that to after the initial page content is already rendered. And here I have this nice diagram that has some main content and marks some parts of this page that could be async. So even on a component by component level, you could load that stuff later. So yeah, if there's one thing I want to leave you with is that you should check this out, try it out, and get involved in the conversation. So here's another link to the pull request on GitHub, and thank you for watching. And yeah, I'm happy to answer any questions. Ben told me all the details.
That's pure awesomeness, first of all. Secondly, so would the caching work, obviously, with Meteor, even if it's not on a particular hosting provider? I guess it would come with its own server for serving modules.
That's right. Ben gave the demo by deploying on Galaxy, but there's nothing Galaxy specific in this implementation. The only thing he was trying to demonstrate there was because Meteor runs differently in production and development, he wanted to show that it's even faster in production.
How does it work for Cordova?
Yeah, so for Cordova, we haven't implemented any specific Cordova-specific features yet. For Cordova, we would obviously want to preload all of the initial app code, because when you're downloading that app from the App Store, it's not really going to matter whether or not it's a couple kilobytes more. But there's definitely an opportunity here to have a system that also individually loads modules for Cordova, so that when you're doing an update of your app, you don't have to reload all of the code again. But that hasn't been implemented yet because we're still in an early beta stage. So if that's something you would be interested also in contributing to, that could be a really good opportunity.
You mentioned something about when you import with different parameter names, parameter name changes based on the latest import. How does it affect the actual code that originally had the original different name?
You mean the live binding thing from ECMAScript modules?
Mm-hmm.
I think it's a bit of a different feature. What I'm talking about is, let's say you have a module called like my favorite number, and the only thing that module does is it says like export var x equals 5. And then you import that module in 2 different places, right? You might think that that will create 2 copies of that variable, so if you change one of them, the other one's not going to change. But for your module system to be spec compliant, it actually does have to change. That variable should actually be the same exact reference in every module that imports that other module there. And if you're using require in Node today, it would actually create a new variable, which means that inside Node.js, With require, you wouldn't actually have variables in other places change if you updated them in one place. So basically, this is like one feature of ECMAScript modules that's significantly different from CommonJS as used in Node.
Is it difficult to integrate an existing Meteor 1.4 project to 1.5?
No, you should just type this command and then you're done.
Okay.
If you can identify, right now, one thing we don't have yet is we don't have tools to help you identify how much bundle size you're saving by using dynamic imports, but that would be very useful, you can imagine. So if you know for a fact there's a module you're using only in one place, then you can try this today and you will definitely be able to confirm that it loads asynchronously. But if you have a very complicated app, you're definitely going to want some tool that will tell you like, oh, if you asynchronously import this chunk here, you'll save like 300 kilobytes or something. But yeah, you can definitely use this today, and it probably will work with your existing app, although it's still in beta. So.
All right, thanks.
All right.
Cool. Thanks a lot, everyone.
Yeah, we're out of questions, so let's thank Sashko.